Welcome, everyone. Thanks for joining this session. So today it's all about TypeScript. If you want, you can try to follow along. Like if you have a laptop or something, you can try to follow along as well. There'll be a lot of coding. So a little bit about me. My name is Deepu K. Sasidharan. I'm the co-lead of JHipster, a very popular framework, rapid application development framework. I work for a company called Zibia Labs, based out of Netherlands. I've written a book, by the way. Little bit about Zibia Labs because they're paying for the trip. So, yeah, we are a DevOps. It's a DevOps platform for the enterprises. You can do release orchestration, deployment automation, DevOps intelligence, all sort of fancy stuff with that. So, what about you guys? How many Java developers here? Can I see a show of hand? Okay, not surprising since this is Devoxx. How many web developers? Okay, not bad. And how many of you are JavaScript developers? TypeScript developers? Okay, not bad at all. How many of you actually like JavaScript? Not bad, huh? How many of you like TypeScript? Okay, almost the same crowd. What about like Angular, React, Vue.js, these kind of things? Are you working on these? Okay, not bad. And how many of you haven't used TypeScript? And are you willing to try? Okay. Anybody who hasn't heard of TypeScript? Okay, I would have been surprised. Okay. How many of you like TypeScript better than JavaScript? Okay, so I assume that this crowd already knows TypeScript pretty well. And they are probably just passing their time here. Okay. So today what I'm trying to do is like have a little bit of backstory or like why people hate JavaScript and those kind of things, just to keep you guys entertained. Otherwise, some of you might just leave halfway. So, and then we'll see how you can use TypeScript for your existing JavaScript projects without having to rename your files and that sort of stuff. And then we'll see all the features of TypeScript. We'll see about advanced type checking. We'll see how you can set up what sort of build tooling that you can set up, which is optimal for working with TypeScript, and what kind of IDE or editor which is best suited for TypeScript. You'll also see how you'll also see some of the projects written in TypeScript, like React and Angular projects, and see how it is structured and how it compares to code written in JavaScript and why it is better. And also, yeah, bootstrapping TypeScript projects. We'll see about those. This I think nowadays it's not entirely true anymore, but I can still hear, especially Java developers, cringing or like shrugging whenever they hear JavaScript or like TypeScript or anything associated with this front end. I have even heard some people completely dismissing JavaScript as if it is not even a language. Like it's like JavaScript. Oof. So I'm pretty sure there are still people who don't like that, but there are some reasons for that, and some of them are fair, some of them not so fair, some of them are just perception, which is kind of blown up by the community probably. Like 8 years ago, we were having jQuery and having fun with it and being happy because you didn't have to write any front-end code. You didn't have to write any front-end MVVM code, right? So the only front-end stuff that you used to write is some jQuery scripts and stuff like that, and you were like fine with it. You didn't have to deal with that, right? But nowadays, when you're doing a full stack development, you have to deal with a lot of JavaScript, and you like it or not. Most of the projects, if you take like a web project, you'll have more JavaScript or like a front-end code than your back-end code, right? in most of the, say, an Angular or React application, right? You'll have more front-end code than back-end code. And full-stack developers who originally were like Java developers, they still are not extremely comfortable with that, the idea of doing more front-end than back-end, right? I have seen that with my colleagues when we have a React project where there is a lot of front-end and equal and back-end, but then you have to do a lot of front-end. Then it's always like people are waiting for somebody to pick up that ticket, right? Like waiting is, okay, we'll take the bait, right? I think the reason for that is the rise of the MVVM frameworks. Unlike in Java or like most of the other stable languages, where you don't see a framework or like a new library or something every day, JavaScript, that's like usual business. Every day you have a new framework, you have a new library, and you start learning something, and the next day it's like obsolete or it's like not cool anymore. You have something new, then you'll be like, now damn it, I have to learn this. And what about the fancy thing I learned like a week ago, right? So I think that also adds to the frustration a little bit. And too many of the frameworks also doesn't help. It's good to keep the ecosystem competitive and on the edge, but when it becomes too much, it's also not that great. Then you cannot follow everything along. You will be confused on what to choose. Even now, when you start a new web project, right, you're always confused. Okay, whether to go Angular or React or Vue, right? You always have to make that decision. So whereas you don't have to do that often in like Java or like in say Scala or something like that, right? So there's an official name for that, yet another framework syndrome. So I think this didn't help much. So there's too many options, too little time to learn that, and too difficult to keep yourself updated. And if you want to be updated on the front-end landscape, you really have to be extremely passionate and willing to spend that much time keeping yourself updated in all those frameworks, all those libraries that you have, like, right? And following all those, it takes too much effort. So we can't do much about that, unfortunately, because that's how the JavaScript ecosystem is, and being the biggest ecosystem. If you look at any programming language, JavaScript is the biggest ecosystem. You like it or not, it has the most number of libraries or like frameworks, and it's the biggest ecosystem. And NPM is the biggest library repository, or like, right? So we can't change that, but one thing that you can do for especially Java developers who come to the front-end world and who find it not as like, you're used to static typing, you're used to having content assist when you work on your IDE, you're used to having refactoring in your IDE and all these things. And when you come to JavaScript world and when you don't get all those niceties, it's obvious and it's fair to assume that you get frustrated sometimes. So one way we can help that is with something like TypeScript. So what is TypeScript? So only for those who are not very familiar and for the sake of completeness. So TypeScript is a superset of JavaScript. It is syntactically strict. That means anything valid in JavaScript is valid in TypeScript. So you just take a JavaScript file, if you rename it to TypeScript, it should work. So it's just a superset of JavaScript, and it supports all the latest and greatest ECMAScript features. And currently, the latest version of TypeScript supports up to ES10 or ES 2019, which way you like to call it, right? It supports all the greatest and latest features. So it is also called as JavaScript that scales by the TypeScript community. It has static typing support, which is optional, which is not mandatory. You can always use TypeScript without the type system as well if you want the flexible nature of JavaScript, and if you love the flexible nature of JavaScript, and if you're okay to deal with all the type errors that comes with that. It transpiles to JavaScript. It is maintained by Microsoft, and there was a huge effort from Google as well in the beginning to and I think the collaboration is still ongoing. And there is a huge community behind TypeScript as well. And of course, the last point is, I think, the most important for developers. It has great IDE and editor support compared to JavaScript. I will see about that later. So this is my personal opinion. I hate transpiling my JavaScript code. I have been doing JavaScript for almost like 10 years now, and I hate transpiling my code. I'm so used to doing my change and seeing the result immediately, and whenever I have to wait for the transpilation to complete to see my result, it kind of, I still don't like it. I hate it. But if I have to do that, I would always do it with TypeScript rather than doing with, say, something like Babel plus this or Babel plus that or something else. The reason, if I'm going to spend that time transpiling and waiting for all of my changes to appear, if I'm going to always lose that time, I as well as have all these along with that as benefits, right? If it is only transpiling, why would I want to wait for my code to transpile if it is not giving me any additional benefits? But at least TypeScript gives you a lot more than just type safety. So it gives great IDE support, of course. It helps you to refactor your code. We'll see those along the way. Better linting and error identification for your code compared to JavaScript or just other transpilers, which only gives latest features. Of course, all the latest features you also get that by default. And if you're doing React or Angular with TypeScript, the code style is much better. I mean, of course, it's an opinion or it's perspective, but you can see it is less verbose than writing in JavaScript, like especially for Angular. If you're writing Angular in JavaScript, I don't even think anybody does that. Has anybody written Angular in JavaScript ever? Whoa. Salute to you guys. So you know how verbose that is. And even for React, which is not as verbose as Angular when written in JavaScript, TypeScript makes it a little bit more concise. We'll see that later. So at a glance, so these are what TypeScript offers. So of course, static type checking, type inference, type aliasing, all those things. You have complex types for, you have union types, intersection types, function types, hybrid types, a lot more. We'll see about those. You have generics, which is very good. If you're coming from Java, I'm pretty sure you miss generics, right? You have decorators or annotations, however you want to call it. You have mixins, which is similar to Scala traits. Not exactly, but almost there, right? I mean, technically, it's not a TypeScript feature mixin. You still have to do the mixin yourself, but TypeScript supports that particular syntax or that particular way of usage. And of course, you have additional language features, and some of them are already additional language features. You also have interfaces, enum support, tuple support. You have modifiers like private, public, protected, read-only, these kind of modifiers. And you have JSX support. And of course, with TypeScript 3 or 2.7 or something, you can also type check your JavaScript. So let's get started. I'll sit down for this. I don't want to stand for like 3 hours. So to start with, you just need 3 commands. You install TypeScript, of course, globally. Or if you want, you can also install it local to the project. I would prefer to do it globally. And let's switch to my... So I have already installed TypeScript. I'm just going to run it again. Who knows? There might have been an update. No. So let's start. I have to delete this first. So init a TypeScript project. So you will see, you'll see it creates a tsconfig JSON where you can see all of the available properties commented out. Easier if you're learning, otherwise you just have to remove them. So you can see some of the basic stuff that we have to be aware of. So there is this target property. So this specifies what you have to transpile down to. So by default, it transpiles down to ES5, which is the least supported version in most of the browsers. Of course, if you're targeting only evergreen browsers, you can transpile down to ES6 I think ES7 also is possible with evergreen browsers. But of course, the point is if you don't use IE 8 or IE 6, or who uses IE, I mean, anything other than IE 11 still in your projects? Okay, I feel your pain. I have been there. Working for an enterprise, I have been there. So I feel your pain. So yeah, so if that is not a problem for you, you can always go down to ES6. So for this demo, let's do in ES6, so that it is easier to compare our code, because ES5 code will be too verbose for us to compare, and yeah, it doesn't make much sense. So let's stick to ES6, and of course module system. So you can do CommonJS or ES6 modules. Let's stick to CommonJS because that is the module system most people are familiar with, and I think that is a module system most people still use. The ES module system is still not as widely used as CommonJS. Of course, there are other options. We'll see some of them later. And let's start watching our project so that it starts a TypeScript server and starts watching for our files. And whenever something changes, it builds it automatically. So the transpilation is ever running, right? So we'll see how we can use TypeScript in JavaScript files. So you can see this property, right? Allow.js. So this is the magic property. So by enabling this, TypeScript allows you to work on normal, say, JavaScript files. So let's say I have this file. Sorry. There is also one thing you need to do. When you're doing JS, you always have to set a out directory. If you don't have an out directory, it's going to overwrite your JavaScript files, because TypeScript by default transpiles to JavaScript with the same name, right? So you have to specify an out directory. Let's put it in build. Let me delete my existing build from my old stuff. Build, and let me restart my watch. Yeah, so it should start transpiling everything into my build directory. So I'm going to delete this one, which was created just now. So ignore the other files, they are not important for now. So I have this JavaScript file, right? So it's a JavaScript file, but TypeScript has already started checking it, right? It already started, complaining about stuff that makes sense normally, right? Say, for example, you cannot redeclare a name because name is by default attribute available in your scope. So let's say, and you can see here, TypeScript complains this argument is not assignable to parameter of string. And why does it say that? Because here you can see that we have some Java doc with which we can actually specify the type in JavaScript files. So if you're doing JavaScript files and if you still want to specify types, you can do it with Java docs. TypeScript supports that. So it supports JS doc syntax. That means it already knows that say hello takes argument called somebody, which is a string, right? So this is nice. So you don't have to, unlike say, for example, FlowScript, you don't have to add custom syntax which has to be removed from your output code. So this is just plain JavaScript which can be run as it is without any transpilation, right? Let's try it out. Let's fix our error. Let's say and let's run it. Node, right? So it works without any transpilation. Of course, this transpilation builds it into the build folder, but we are not running that. We are running the file directly here, right? So, and also one more thing that we have is check.js. So allow.js, you can see the description here. Allow.js allows you to compile JavaScript files with TypeScript, and check.js allows TypeScript to inspect your JavaScript files and start reporting errors if there are any. So it's not required that you have to use both. You can just use allow.js for things to be compiled. That means with allow.js, you can use newer syntax of JavaScript and transpile it down to ES5. So it can be used for that. So TypeScript can just be used as a transpiler for your code without using any TypeScript specific features. For plain JavaScript, where you only have to use, say for example, you want ES9 feature. So you can use allow.js. And of course, check.js is if you also want to do type checking and all those things in plain JavaScript files, right? So there are also these two special comments that you can use. So here I already have this TS check, right? And that is why, so say for example, and that is why this was working without this one. So if I disable this, if I go back here, and if I remove this, TypeScript won't do anything. It still compiles the file because you have turned on allow.js, so it still compiles the file. That means if I use a newer feature, it's still going to transpile. Let's see what it transpiles down to. So this is the original file, and this is what it transpiles down to. So let's try to let's say target ES5. Probably I have to restart this. Okay, yeah, CS5. So you can see that it transpiled the ES6 features to ES5, right? So with only allow.js, you can use it as a transpiler. And with this syntax, also you can enable type checking without having to enable it project-wise. Because if you do it here, it does it for the entire project. So if you have an existing project, and if you have to type check only certain files, you can do this. And also you can do the other way around. You can enable it for everything, and for specific files, you can disable it by this particular comment as well. So both are, so it's flexible, right? So let's fix it. Everything is fine. Yeah. So that's working with JavaScript. And of course, these are not the only JSDoc styles that are supported. It supports a lot more. You can look at the TypeScript documentation for all the JSDoc syntax that is supported in plain JavaScript files. It's quite handy. Say, for example, you can also make this optional by doing this. Now it won't comply if I do this. Now it will comply, right? So it's quite handy. But of course, this is not the focus. This is good to have if you have existing projects. This is also a good way to migrate to TypeScript if you have existing projects. You can introduce TypeScript, and you can slowly start to type check your files, and like you can do the migration slowly as well. Let's dive into TypeScript features, because transpilation is not that great. The extra language features, those are great. So these are the basic types that TypeScript supports. Of course, you have primitives. You also have boxed classes for them. But don't do for TypeScript is never use the boxed class for a primitive. If your type is Boolean, use the primitive one, not the boxed Boolean object. Because you will always find, say, for example, if you're, let's switch to this file. And for here, let's switch to this one. So I can always do constant foo. Right? Okay. Never do this. This is a box type. Never use this. Always use Boolean. Especially because in JavaScript, boxed classes are notorious and they are not that great. So always stick to primitives. You have number, string, string array. So array can be used in two different syntaxes. Of course, preferred style is always to use the string brace notation like this. Or like your type, and then this is a preferred notation because it's more concise. Of course, you can also do the other one, but most of the default linters, say for example, if you are using TSLint and if you are using the recommended styling, then this is not the recommended. The array syntax is not the recommended one. And also you have special types. So any, I think if you're using TypeScript already, you would be very familiar with any. How many of you always type everything as any to start with? Yeah, I do that sometimes as well. I think it's like something you learn when you start migrating stuff, because as soon as you find an annoying error, the first thing you do is okay, any. Then later you try to fix that. So it's of course not a good way to do that, but yeah, it's there. Sometimes it helps, and sometimes any is required. There are valid use cases for any, otherwise they wouldn't have built it, right? And of course you have a object type. So this is very similar to any, but it is specific to objects, like object literals. So you can also use that instead of any to type unknown object, because any is for everything, whereas object is more limited, right? You also have tuple. So tuples are technically arrays, because you can see they will compile down to let's say string number, and let's say you can see it's just an array. But in TypeScript, you can use the tuple syntax, which makes people feel nicer, I guess. You can also alias tuples to build your own tuple 2, tuple 3, up to tuple 24. I hear there was up to tuple 24 in Java, 24 in Scala. Or is there more? Is it 24? Still? Is more? Okay. I don't know why someone would need a tuple with 24 items in it. But yeah, you can do that here as well. There is no limit here. You can do a tuple 100 if you wish. Pass 100 items. And you have some of these weird types. Void, of course, void makes sense when you have a function and if it doesn't return anything, right? There you will type the return as void, so it makes sense. And the only thing that you can assign to a void type is undefined. Then you also have undefined as a type. Obviously, you can only assign undefined to an undefined type. And also you have null, to which you can assign undefined or null. These are also useful in some corner cases, special cases where you have, say for example, you have strict type checking enabled in TypeScript. Say for example, you have, so you have strict type checking. That means when you type something as string, it won't accept when you provide a null to it. Say, let's see it. So it doesn't accept that, right? So if you want a type to be nullable, then in strict mode, then you have to do this. Or the same goes for undefined as well. So this is only in strict mode. If you are not using the strict mode, then by default, all types are nullable. So it's useful that way. Then you also have this special type called never, which is to indicate this is useful only in functions. You can't use never for any other types. In functions, you can type the return as never, which tells TypeScript that this function will never execute. It will always throw an error, right? Or it will never reach the end of the function. So that's the way of saying that. So these are all the types that are available. Then you also have enums. So enums are generally you can have like let's see. So this is a standard enum. You can assign it as a type to some variable. Foo is equal to color. So you can use it as a type. That means foo will only accept something from that particular enum. You can also have enum with numeric values, which is by default enums have running numeric sequence as values. You can also override them to say have this instead of the default 1 and 2. You can also do this. And also with TypeScript, you can also have I think it's a newer feature. It's a recent one. You can also have values, string values. But there's a catch. You have to put it in double quotes. It doesn't work if you. Oh, it works. Sorry. Yeah, okay, sorry. Only this doesn't work. Yeah, you can't use literals. You have to use single or double quotes. You can't use literals in enum values. So you can also do this. So yeah, of course, all flavors of enums are supported as well. Now, interfaces. So of course, ES6 introduced classes, but still there are no interfaces. So I mean, not exactly. So TypeScript gives you interface. So let's say I might have this. So this is an interface in TypeScript, and if you look at the generated JavaScript code, I don't know why, weirdly VS Code doesn't reload files as they change. So you can see I always have to switch out to change it. I tried to fix it, but I didn't have enough time to get along, so it's fine. You can see that it doesn't generate anything because this is understood only by TypeScript. It doesn't mean anything in JavaScript, right? So let's now you can see it created a simple variable, which is an object from this, right? We are still compiling down to ES5. Let me switch it back to ES6, which is a bit more nicer to read. Oh, I didn't have to restart it actually. Nice. So we have a person interface which defines the contract, and you can assign it to any object, and it will say, for example, let's say foo, and voila, you will, that's expected, right? But the nice thing about having interfaces and assigning interfaces to your types, object types, is that you can do this, which is nice, right? I mean, we always do that in Java and other languages, but with JavaScript, one of the issue of by not having any typing is when you're refactoring stuff, you always have to refactor by find and replace, right? You can't go to a particular function, refactor something, and expect your all occurrences to be nicely handled. That doesn't work. But with TypeScript, it works for most of the cases. Like if you have a interface declared, you can always rename the interface, and it will rename all occurrence of the interface implementations. So which is very nice if you're refactoring stuff. You can also have, say, for example, some special things in the interface, like you can have read-only properties. So let's say you can't do this because you have marked it as read-only. You can't assign to that. It will complain that it's sorry. Oops, my bad. Yeah, it will work here actually, but you can't do here because you're just constructing it. You have to assign the value when you construct. You can't do this because TypeScript will complain It's a read-only property. So you can mark some of your properties read-only. This is especially useful if you're working with, say, state management systems, like, say, Redux, for example, where you can't mutate your state, right? So marking your state properties as read-only with TypeScript will make sure that you will never mutate your state properties, because it will always complain and your compilation will fail. Otherwise, it's possible that sometimes you accidentally mutate a state and then you spend hours figuring out why your view doesn't work because you mutated your state. So it's quite useful. Also, say for example, if we didn't have this, and you have a valid use case where you still need the object to be typed to a particular interface, but you also want to add additional properties, which is very common in JavaScript, right? In JavaScript, it's quite common that you have some object and you dynamically assign some values to it, because JavaScript by nature is a dynamic language, and that's one of the power of JavaScript, that it allows you to do crazy stuff, and sometimes it is useful. So if you want to do that, especially as library developers, or if you have a complex requirement where you have to assign unknown properties to an object, so this particular syntax will prevent that, right? So what you can do is, you can say, let's say this should always be string or number. Why does it fail? One second. Why does it? I can't have these here. Yeah. So we can define this is called excess property. So you can define an excess something like this, which means your object can assign anything with a keys string and value string. You can also say, for example, if I do this, then it will not accept this, but this. So this is also a way of defining a generic kind of types. Sometimes these are required. So that is also supported. Function interfaces. So let's say see an example. Really? I'm just going to collapse this. Okay. So you can define interfaces for functions, and this is the function's signature. So this takes 2 arguments of number and returns a number. And you can assign that particular interfaces to your functions as a type, right? So this is quite handy as well. Nothing fancy there, so not going to go into anything. So implementing an interface. So we had a person interface, right? Let's see how we can, let's see. Yeah, so you still need a person interface. Yeah, so we have a person interface, and you can also implement that for a class, right? But of course, when you implement an interface, you have to, like in every other language, you have to implement all the declared properties. So, but yeah, declare all the properties and have a constructor. So it's quite the usual way. There's nothing fancy about this here. Let's see what it created. So it just creates a ES6 class, right? Nothing fancy about that there. But you can also say you can extend interfaces and if you use this, it will complain that you didn't implement foo, which was declared in the extended interface. So let me go ahead and implement that. Now it will complain that you didn't initialize that. Of course, you have to initialize that. Okay, I don't know what happened there. You can also do this. You can define an interface, say foo, extends you. This is also valid. So you can also extend classes for an interface. In this case, none of your implementation will be copied over. Only your property declarations will be copied over. So this is also valid. So I can say this is also a valid way of extending interfaces. So this particular features are very useful when you do some real world type modeling. You always have to create base interfaces and create additional interfaces based on the base. Otherwise, you would be creating a lot of unwanted duplicated code. So this avoids that. So as you can see, like there is nothing on the JavaScript side. It's only the class, because everything else is only understood by TypeScript. And of course, class inheritance, I don't have to go much about here. Of course, it's a ES6 feature. TypeScript also supports it natively, which you don't have to specify because TypeScript is a strict superset. That means every JavaScript feature is a supported TypeScript feature as well. But what it has, though, are class modifiers, which you don't have in JavaScript. Of course, JavaScript, the latest version, is introducing the private property with the hash in front of the property, something like this, which I think still doesn't work. Sorry. So something like this is being proposed in JavaScript, but it's not as good as having this, right? If you're coming from Java, you're quite used to this syntax, and it's quite nice actually. So yeah, you get the same private, protected, and public items, which has the same meaning as in Java. So private is private to the class. Your inherited classes will not get it, will not see it, and protected will also be seen by your inherited classes, whereas public is open for everyone. Then you can also have read-only properties, which is same as what we saw in the interface. So these are the class modifiers available in TypeScript. So you can also have a static property. So of course, JavaScript has static methods, but doesn't have static properties. With TypeScript, you can have static properties as well, which is extremely useful if you're doing, say for example, if you're doing React, you can declare your default props as static props, or you can define your state as a static prop. So it's extremely useful there. It makes the syntax much more concise there. We'll see about those later, probably in the second half. And of course, you also have abstract support. So classes can be abstract. So you can say, so I can't so it will complain that you can't create from an abstract class. So of course, abstract class is also useful when you are having an inheritance based model. So TypeScript also supports function overloading. Probably not many of you might have tried this. It's a slightly weird syntax, but it's useful, especially if you're writing a library or like an API. It's really useful. So let's see. No. Oops, I didn't. Probably I didn't create a. Yeah. So you can see our add method. So this is our add method, right? So it takes x and y, which are of type any, and it produces an output of any. And within the implementation, you can see it checks for the type and does an action accordingly, right? And you see these two weird declarations here. So this is how you overload functions in TypeScript. So you just define them before your actual function, and your actual function should have this particular syntax. So this means this method actually only has these two syntax which TypeScript recognizes. This is only for internally for TypeScript. It doesn't let you actually pass, say, something like this. Because you might think that having an any might let you pass this, right? It doesn't. This is only for TypeScript to know that this is an overloaded function being overloaded by these declarations right in front of them. So this will still be considered wrong. And if you run this, so I have to run it from build main.js. Okay, I have to console log them. So yeah, this is nothing fancy of TypeScript. This is just plain JavaScript. But TypeScript doesn't complain for these two syntaxes because we have declared overloaded functions for this. This is extremely useful if you're having a library or like an API which other people are using, and if your function is polymorphic, it supports multiple types of input-output, then you can do this. I mean, it is not required that you have to have a same number of arguments or anything. You can also do this. This is also quite valid. And then that means your function call has to be like this. That's all. So you can have, where does it fail? Yeah, because of we don't have a implementation. So TypeScript is smart enough to analyze a function and say that we didn't implement for this particular use case. So that means you would have to have a check for this particular use case and implement that if you had the overloaded function. So let's go back. So that's about function overloading. Generics. So this is a topic of interest for Java developers. Let's see. Yeah. So we have a class here. Let's see what it transpiled to first. So it just transpiled to a simple ES6 class, right? There's nothing about generics here. But in your declarations, though, you can always have a generic. And this instantly makes your interfaces happier, right? Because you don't have to duck type every known types or create interfaces for all the variations you have. And this is, I mean, if you have used generics in Java, you know how useful it is. So I'm not going to go ranting about that. So by having a generic, you can have these two usages where the first one is taking a string and the second one is taking a number. Both are quite valid, and you can say, let's greeter dot right. So TypeScript also lets you do something like extends, similar to in Java. Let's see with a better example. For example, yeah. So you can see, let me collapse this a bit. So we have this function which is having a generic type for argument, and we say that this particular generic has to extend this interface. So you can't, so this way you can actually access properties within the function of the generic. Otherwise, TypeScript doesn't know what this particular generic would be. And if you say, for example, if I don't have this, it says length is unknown property because TypeScript doesn't know what the generic could be, right? So this way, you can say that it extends a particular interface. So it can be any object that extends this particular interface. So it's quite useful. And another feature is modules. So of course, it's not new, but TypeScript has been supporting modules for quite a while now. It used to support CommonJS modules, and now it also supports ES modules. That means you can pretty much do import exports on your function stuff. Module, no. Yeah, probably I didn't type it as well. Yeah, but there's nothing to show here. So let's say we don't have any library to import. I wanted to show the difference of what is generated. Let's just export our class, for example. So it does a CommonJS export because in the tsconfig we have specified module system to be CommonJS. So it automatically creates a CommonJS exports. Also, you can also import stuff. Say, for example, yeah, of course I don't have the library installed, but you can import them, and you can see here. Yeah, I mean, I think it won't compile because the library is not available. No, it is dead code removal. Let's say yeah. So it does the CommonJS request syntax. Of course, why you didn't see that before is TypeScript also does dead code removal. That means anything unused in your actual code will be removed in your final output, transpiled output. So also called as tree shaking. This is the example I had for the modules. Yeah, nothing fancy there. So TypeScript also has a concept called namespace, which is not exactly same as modules. So namespace is nothing but just having, say, for example, name. So if you look at the compiled output, it's nothing but just an object with properties associated to it. And also the syntax looks very much similar to that, right? Like it's just an object with properties to it, so that in your typings you can say validation dot validator. So it's like sandboxing. So you can have similar types defined across multiple namespaces, and you can choose to use whichever you prefer. So it also has that. This is mostly useful for library authors and libraries and APIs stuff. Mostly you might not use this feature a lot in your actual code, but you might have come across this whenever you are trying to figure out how to fix a particular TypeScript type conflict issues. You might have declared this using a namespace in your typesings.d.ts files, right? Decorators. So Decorators was originally from AtScript, Have you heard of AtScript? Anybody? AtScript? No? It was actually being developed by Google for Angular 2 actually. So that is how the collaboration between TypeScript, Microsoft and Google happened for TypeScript, because Google was developing AtScript for Angular 2 and Microsoft was developing TypeScript, and then they kind of decided to meet. Both were doing same things. AtScript was also trying to do similar things as TypeScript with some extra features, and then they realized that, okay, TypeScript is also doing the same thing. Why don't we just merge both together and have a single community, which is a great decision, unlike how some communities just decide to split and have two communities doing the same thing. So having a single community makes it easier for adoption and makes the community stronger, right? So this decorator feature was from AtScript actually. That is why Angular uses annotations or decorators heavily, because they were specifically developing AtScript for Angular 2, which was heavily depending on those. So TypeScript also added support for that. But keep in mind, it's not enabled out of the box. Say, for example, if I go here and let's say, I hope I have some samples saved for this. Yeah. So you can see it doesn't work yet, because it's an experimental feature. I don't know why it is still experimental. It's been a few years since it has been there, but still considered experimental. You have to go to your file and you have to enable this. And yeah, there is a missing. So now it recognizes this, and you will see a lot of weird code in your output, regardless of what you transpile it to. So this is like the glue code that TypeScript requires for this stuff to work. And you can see that it uses reflection a lot. And if you're writing decorators, you will be using reflection a lot. That's how it works. But it's quite useful. Say, take this sample, for example, right? So we have a class, right? And we annotate this method with this particular decorator, right? And what would you expect it to do? Let's run it. So you can see hello there was printed from this particular console log, right? You can also see this particular log, which is from this. And this is just a function which takes a predefined set of arguments. This is like the standard syntax for decorator. It accepts a target, which is like your target class or the target function or whatever is your context, and a key of the property being assigned to, and the descriptor, which is like the reflection metadata for the entire thing. So using this, you can do a lot of stuff. You can manipulate fields, you can manipulate class properties, you can manipulate method invocations and stuff like that. So this is quite useful, right? So let's see another example. Here it's the same thing. Here it's the same thing, but when you run it, you actually see a different log message. It also prints out the arguments now. And in order to do that, what we did here is like, so the value from the descriptor is the value of the particular property or method or whatever to which you are assigning the decorator to, right? And value of this would be a function actually. So we assign that to somewhere, like to a holder variable. And then we override that with a new function which adds a console log and then just invokes the original function. So this way, you can manipulate function calls to add additional behavior. So say, for example, you can add a pre and post hook kind of things. Or you can also add, change output property. Say, for example, the function is returning a certain output. You can also manipulate that with this particular way of doing stuff. So this is how you can use decorator, for example. And one second. There are also so you can do decorators on methods, which we saw. You can do it on classes. That means you can have a class level decorator. This is what you would have seen a lot in Angular, also method level, but more class level ones. You can have it on properties, which can be used to say, for example, initialize properties or like manipulate properties. You can have it on method parameters. You can have it on accessors. So let's see another example. Okay, so we have this class, right? We already saw the log method, which works on the particular method. You can see init here on the class level. So let's look at the some of the parameters here, right? So we have these two, right? And you can see the value is initialized to be empty, right? So if I run this, what would be the output? What would you expect to be the output? So the output is, of course, it was called with no arguments because I didn't pass any arguments to this particular method. And you see for this output, right? It is returning a string version of first name and last name, and I'm console outputting it. It's actually printing something, whereas it should have been empty, right? And how it happened is with the init decorator, right? So it's quite a simple decorator. You can see it accepts a constructor, because if you are applying on a class level, it will get the constructor. So we are extending that to override our properties with some values. So this is one way of using a decorator. Of course, this is not like a realistic use case. You won't be doing stuff like this often. Sometimes you might. But there are a lot more use cases for decorators. I mean, you don't have to look further than Angular. Angular uses decorators effectively to reduce boilerplate a lot. I mean, the guys who have written Angular in JavaScript would know the difference, right? All the boilerplate that you have to add if you don't have the decorators. So it also makes it more concise and easy on the eyes, right? More readable and more descriptive kind of thing. So you see this weird type declaration? Yeah, it's required because so we generify the function. We say it uses a generic, but we can't just use any generic. Say, for example, if we do this, it wouldn't know what this constructor is, right? It doesn't know what it is. It doesn't know why I am extending this, right? It can't extend something if it doesn't know what it is. So we say that this generic type, which is constructor, of course, it's of type T, which is generic, has to extend this weird looking guy. So it has to extend a constructor syntax which accepts any number of arguments, which is like a var, right? And produces an object output. So that's the fancy way of telling that this has to be in a constructor form. So then at least TypeScript knows, okay, how to extend this, right? And don't yell at us for that. So that's about decorators. I didn't go into these decorators. Of course, these are kind of simple use cases. If you look at, say, for example, let's handbook decorators. You can see a little bit more complex use cases here. If you go down all the way, don't look at the big initial ones. They don't explain much. Yeah. If you look at these ones, you can see what you would actually do when you write decorators for realistic use cases. You will be using reflect metadata a lot. Trust me, you'll be using that a lot, because you have to use a lot of reflection for this. And reflect metadata is a library provided by TypeScript, which gives you a lot of utilities to do that. Like, say, for example, you can get the metadata out of your properties and descriptors. So it's quite useful, and you will be doing say stuff like this. This is a simple implementation for a required validation on a property, and like so you can go through these examples if you're interested. Let's look at our next item. Okay, mixins. This looks fancy. Let me put it here. Yeah. So let's say we have classes like these, right? So we have a runner. It has some properties. So it has a speed and can run. We also have a swimmer. It has speed and can swim, right? Then we have a person which implements. See the difference? It's actually implementing classes, not interfaces. Normally, you would expect when you like in Java, right? When you implement, it has to be an interface. You can't implement a class. But in TypeScript, it allows you to implement classes as well, because TypeScript will treat that as an interface. It won't copy the implementations over. It will only copy the declarations. So this will give you a person with this also as declarations. Say, for example, let's do something like this here. Okay. No, it has to be like this. And what does the person need? What is wrong here? Sorry. I didn't mention that. I think I'll mention it later. TypeScript also does type inference. You don't always have to specify types for everything. For most of the cases, TypeScript does pretty good inference and it works pretty well. Say, for example, now it knows that this particular property, variable is a person. And if I do, say, for example, constant foo is equal to 10, I don't have to type it. It wouldn't complain because it knows that it is a string. It's quite straightforward, right? And it does this inference pretty well. And by each version, it just keeps on improving the type inference. So you don't, in realistic use cases, you don't have to type everything. You only have to type whenever it complains, normally. Otherwise, if it doesn't complain, don't worry about it, because it can infer that and it works pretty well. So let's see. Our person now has run, set speed, and swim, right? Because, of course, we implemented these two, which are treated as interfaces. That means if you don't have this, it wouldn't work. It will complain that you didn't implement something that you have declared, right? So you have to implement everything from those classes as well. But then, see the difference here. So I have this class, so speed is set as 0, right? And I have a method here which sets the speed. Then I have swim, which returns 0. I have run, which also returns 0, right? And let's remove this. Don't need this. And let's forget this for now, this particular line. We'll come back to that. So here we have this initialization, right? So I have a person, and I have set the speed to be 10, and I'm calling the swim method for the person, right? So actually I don't need a set timeout here. I was playing with it, I guess. Right? So what should happen here, ideally? We have set a speed, of course, but when you call swim, it should return 0, right? Let's see. But it returns 100. How did it return 100? Because here in the original class, we have this, right? But I also said that TypeScript never copies over implementation. It only copies over the declarations, right? Like the contract, right? And this is where the mixin part comes in. So when TypeScript says that it supports mixins, doesn't mean that it supports it out of the box, it only supports this particular syntax. It doesn't complain about this. That's all. Everything else you have to do it yourself. So this is where the actual mixing in happens. So it's a method which you would expect to be global, but no, I have the method here. So if you're doing mixins, you need this method somewhere in your library. So you have to do this once, or depending on different types of mixins that you have. So you have to do this. What it does is quite simple. It takes a class, right? It takes an array of classes or objects. Then it iterates through the array. And for each item in the array, it gets all of its own properties and iterates through them. You can see the own properties of the prototype, not the class itself, right? Only for the prototype. So it gets all the own properties of the prototype, iterates through them, and assigns it to the derived class, that the class to which you have to mix in, right? So it's quite straightforward. Classic JavaScript magic, where you can dynamically manipulate prototypes, right? It's one of the for me it's one of the biggest flexibility of JavaScript, because of this flexibility you can actually do a lot of complex stuff with JavaScript in an easier manner. Of course, that means you would have spent a lot of time making sure there are no type errors and all this thing manually. Probably, yeah, but you in the end you will actually get a lot of concise and nice script which does the thing for you. Instead of having 3,000 or 4,000 lines of code, you can do it in pretty much say some 100 or some lines. And I say this from experience, because like when working on Java Hipster or JHipster, it's completely in JavaScript, and we have done a lot of crazy stuff. Of course, some of the stuff might not sound look like best practices, but for the use cases, those were the best approach to do those kind of crazy stuff, like having parallel processing and all those things. In Node.js, it's not as nice as it sounds when you look at it, but that's how it works, and it's quite powerful actually to do all those stuff. In another language, you would have written a n number of classes and like a lot of code to do that. Of course, there is advantage that it's easier to maintain. You have all the type safety and everything. But you can also do this with JavaScript now. With TypeScript, you can also make it type safe. So you get best of both worlds. You get the power and flexibility of JavaScript, as well as type safety and all those goodness of like a Java-ish kind of language. So that's about mixins. So half from TypeScript and half from you. That's how mixin works. So that's all about the basic language features of TypeScript. Next, we'll see about more complex types like union, intersection, all those complex types, which are more useful. Actually, if you start doing TypeScript, you will hit a point where you can't work with simple types anymore. You would end up needing complex types. And that point might be 1 month from you start, or like 2 days from you start, depends on how complex your project is. If you have a complex project with a complex, like very complex object models and stuff, you would end up hitting this very fast, because simple types can't just satisfy all the needs. Otherwise, you will end up duplicating code a lot. So these complex or advanced types helps there a lot. So we'll take a break now, and after the break we'll continue with complex types and remaining of the session. So how long is the break normally?
30 minutes.
30.
Yes. Okay,
yeah. So I hope to see at least half of you in the next 30 minutes. Welcome back. I'm glad to see that most of you came back. Okay. That means I'm not doing that bad. Good. Okay, let's. So we learned all about the basic types and all the language features. Now let's get into some real business with types, right? So TypeScript provides a lot of interesting ways to compose types and like to define very complex, object models, right? So one of the first thing is intersection types, or from the definition, it's more clearer, right? So you can specify a type which is a combination of other types. So you can have any number of, you can keep ANDing them, like let me go back here. Let's see. No? How come I don't? Okay, never mind. So let's have an interface. I already have a person interface. Okay, let's have this, and now let's say let's also define another interface. Let's keep it simple. Right? So now for foo, you can assign to, say for example, so as you can see, address is optional, and in TypeScript this is how you specify something as optional. You can do that to types, arguments, makes it optional. That means you don't have to specify them. So say hi will be so we have defined person. Now if you inspect, it complains that type is missing, which comes from animal, because we have defined foo as an intersection of both. So in order for this to work, you have to put in a type. So this is how an intersection type works. So you can do this for basic types as well. Say for example, you can have a function. You can say string or number, y is string or number, and say returns also string or sorry no, that's the wrong sample. That is for the union types, not for the intersection type. I went ahead of myself, sorry. So yeah, for primitives, sorry, what I was going to say was, for primitives you can't do intersection, because of course you can't have something which is a string and a boolean at the same time. So you can only do intersections on object types. The other one was for union types, which I'll show next. Let's go back here. Yeah, so union types. So let's go back here. So if I change this to this, it becomes a union type, and it's quite obvious, right? So foo can be either person or animal, right? And it still accepts all this. And what I was going to show was something like this. I was going to say return x plus y, which will complain, of course, but that means you would have to actually do a type of and then return appropriately. I'm not doing that just for now, just to show that how you will define it. So you can define unions like this as well, like for primitives as well, and for objects. So let's get back to what we were doing. So here, so foo can be now either person or an animal, right? So let's try. So, but it's not going to support something which doesn't exist, right? Only this or this. And here, yeah. Let's see. Let's see a better example for union. More realistic one. Let's delete this. Okay. And we still need person interface. And what did I delete? Okay, I think I missed something here probably. 1 second. I think I saved it without the entire thing. Let me type it in. Sorry. So let. Okay, so this should be string. What does it complain? Why does it complain? Because it can't return something because it's a type. So it should be like this. So here you can say let person be swimmer or runner. Yeah, so now this is more appropriate. Let's get rid of this. We are not using it anymore. Okay, let's see what it complains, right? So it says type number is not assignable to string because it is returning a number. Let's return swimming here and running here. So now we have defined for both we have defined the type to be either swimmer or runner, and then we have also implemented the interface. But then if you try to access them, it says it doesn't exist. But if you let's say just try for run now, it says it doesn't exist, right? But if I comment this out, then it doesn't expect any argument. So remove this and it works. So what it does is, when you say a type is either this or that, it can only take one of the type, right? It can be either one of the type. It can't be both at the same time. So when I try to do define both types implementation, TypeScript gets confused. It cannot choose between a swimmer or runner, and it gets confused, and it cannot choose the appropriate property from that particular type. So this is where something called type guards come in. So let's copy this type guard first. Yeah. So a type guard is something, just functions, where you would actually check for types before doing a particular action on that particular type. So union types are useful, but they're also annoying to work with. Sometimes you need union types. Sometimes you really, especially if you have an existing API or if you have an existing project in JavaScript, it's quite natural for you to, from a function or something, return two different kinds based on context, right? It's quite natural in JavaScript to do that. And if you're migrating something like that, it's difficult to type them without union types. You might have to use union types in those cases. And in those particular cases, it's always annoying whenever you try to use those objects which are of union types in further along your code, you'll always get type errors because TypeScript cannot exactly figure out which particular object you're trying to use there, right? In that cases, you always need something like a type guard. So a good practice is whenever you write a union type, always write a type guard also for the union type, so that when you're using those union typed objects in your code, you can always do them inside a safety of a type guard. So it ensures that you always get a particular object within the type guard invocation. So for example, here we have a type guard called isSwimmer. So this expects either a runner or a swimmer, and if the item is of type swimmer, then you can see here it typecasts it. This is how you typecast in TypeScript. So the person object here is being casted to swimmer, and then it checks if a particular property exists for that. If it is not undefined, then this is a swimmer. And in your actual code, this is how you use it. Let me remove the... So in your code, you can see now it doesn't comply, right? Here it would comply. It says it cannot identify run because it's a union type, right? Here you can see it incorrectly identifies it as swimmer. It says that run does not exist on swimmer. It couldn't identify that it exists on runner. So it's like an ambiguity, right? It's quite common in languages. So that's why type guard comes to our help. So here both these cases will work because we have a type guard on both cases. And so if you're writing union types, always write type guards. Without type guards, union types are a pain to work with. They can lead up to hidden bugs. Sometimes when your union types are not complex enough, sometimes TypeScript might not complain. It might pass type checks, but you can also have runtime errors. So it's always a good practice to have these kind of type guards. So always write a type guard if you're writing a union type. So this was a complex union type. And of course, for primitive Booleans, it's not that much of an issue. But for unions which are of interfaces, you always need a type guard. So type aliases. So you might have seen usage of a type keyword here and there. So they're almost identical to interfaces. So whatever you can define with an interface, you can also define with a type. The only difference is with type, you can also alias primitives. Like you can say, let's say, so you can do this with types. So you can create aliases for primitives, for your interfaces, for unions. Say for example, you can say something like this as a type alias, and you can use this in your types. Or say for example, you can create something like So something like this. So type aliases are useful to keep your code clean, and like, say for example, if you have a particular type which is longer, say, or a union type, say for example, like union of say something like something like this. This is absolutely possible to do something like this, or even longer. You can keep on, mix and matching them. I mean, in one of the project I had a type like this which spans like 2 lines for a particular method. So it's possible to, in real use cases, it's possible to write very complex union or intersection types and stuff like that. So here you can always do. Of course, it doesn't exist, but assume it exists. So you can do this, and this instantly makes your code cleaner and nicer to look at, right? So instead of doing this, copying this over everywhere, which is difficult to refactor, you can use a type and use that everywhere so that it is easier to refactor and like to visually glance at and everything. So another difference between type alias and the interface, because as I said, you can do most of the things that you can do with types except for aliasing primitives and like primitives, you can do with an interface as well. But one more difference is in editors or like your IDEs, when you hover over like a type, you can actually see the actual real thing behind it. If it is based on a union or an intersection or whatever, you can actually see that instead of the type itself. Whereas in interface, if you hover over an interface, you will only see the name of the interface. So it's a bit more nicer. But the disadvantage is that type is a very TypeScript specific thing, whereas interface is something that might become a JavaScript standard as well. So it's a bit more safer to go with interface for the time being. Feature safety. You also have literal types, which is really nice to have. Say for example, you can have a type called accepted colors, for example. So you can have a type like this, and if I use this, so TypeScript will not accept this, right? Because of the type definition. But if I do, it accepts this. So this is really useful if you're having an API or a library, and you can restrict parameters. Say for example, in a function, you can restrict parameters being passed. You can also achieve this with an enum or something, but you can also do it this way. So this is also possible. So in some use cases, if you know that you can only handle certain values, for example, right? So you can restrict the input with a type so that when you use that particular API or a method, you can be sure that you will only pass those values which you have already handled, right? So this is quite nice. You can also do the same for numeric types as well. You can do it for numeric types as well. So literal types done. Okay, index types. So okay, this is better explained here. Let me paste my sample. I hope I saved on. Yes. I think I forgot to save some of the samples I worked on. Okay. It's a pluck method, which if you're using Lodash or something like that, you might be familiar with the pluck method, what it does. So you can pluck a particular property from an object, right? So that's what a pluck method do. And for let's not look at the pluck method for now. Let's say we have this interface, person interface with name and age, and we have a object for that, right? And we want to pluck name out of this into an array, right? So this is what the pluck method does. So if we run this as a console.log, so we get an array of the name, right? If we had, when you type this, say, let's remove all the types for now and see how it looks. Let's remove this. Let's remove this, and let's remove this. So in the method, it's quite difficult for TypeScript to understand what is happening, right? And it's quite difficult to generify this because this particular property, right, can be of any type. The object can be of any type. This has to be generic enough to handle any kind of objects. So let's see how the typing for this looks. Of course, you know that you should be using generics for this, but how can you make it granular? How can you make the generic granular enough for this method to work and TypeScript understand it, right? So obviously, we say that this particular method uses a generic t and also k, which extends key of t. So key of is a special keyword TypeScript provides. So this tells that k can be only of type, say, string or number in this case. It can only be a keys type from this type passed, right? So here you are already reducing the scope for the types to the type of the keys in this case. Say, for example, in our case, this person has string and number. So k here, when used with a person type, can only be a string or a number, right? And then in the method signature, if you look at this, you say object, right, of type t, of course. That is what you are passing, the first argument. That's your object. It's of type t. Sorry, type generic t, right? And the names. So the names that you pass can be of type here, right? It has to be an array, right? So you are ensuring that you restrict the usage here to only known keys in this type, right? So here, say for example, if I try, it will fail because it's not a known key here. So by specifying this, since you already said k has to be a key of the type passed, the object passed, you are restricting to only known keys within the type, right? And also here you say the output has to be okay, how do you explain? It has to be an array. That's very evident from this. It has to be an array, but it also has to be a value of the object, right? This is how you type your output as well. So this way, TypeScript is able to understand the pluck method is a generic pluck method which can accept any type of object, but regardless of that, it can always safeguard that your keys used has to be a known key of your object type, and the return type is an appropriate based on the object that you're passing. So here it will only take name, and say for example, you can also pass age, right? Now it complains type number is not assembled to string because it's a string array and age is a number, right? Here this particular thing is worked on. So if you look at this automatically turned into this is the definition that TypeScript interpreted, right? You defined using key of and index typing, but TypeScript interpreted it as pluck can accept a person object, and the key has to be either name or age, and the output will be either string or number, right? So this is what TypeScript interpreted. So if you say this to be any, this will be acceptable, right? So this is how you can use index types to generify your methods. This is very useful if you're writing generic methods, like say, for example, Lodash kind of methods, right? Which can work on, say, maps, objects, arrays, or whatever. So index typing is very useful, and this is the part where you actually do that. And once, since you define this to be a known entry from the object, you can later use these syntaxes to define granular types further on. So that's about index types. This types. So let's see with an example as well. Yeah. So let's say we have, most of these examples are from the TypeScript documentation. I didn't want to invent my own examples for simpler use cases. Only for use cases which, examples which were complicated there, I tried to do a simpler one. Otherwise, I just use the same one so that if you refer back, it's easier to follow the same. So say we have a basic calculator and we have, say, a few public properties. And you might be familiar with this pattern. So this is like forgot the name of the pattern, but you can basically chain them, right? What is the name of the pattern? Yeah, thank you. So you can chain them, and when you do this, it's quite difficult to type this because you don't know because you're always returning this here, right? And it's difficult to say what is the type of this in every context in your method, right? Because you know how this works in JavaScript, right? This is the holy grail of JavaScript. Understanding this, if you understand how this works in JavaScript, then you can go to the JavaScript heavens. Otherwise, you can't. So that is how this works in JavaScript. And if you know how this works in JavaScript, that means you also know how difficult it would be to type functions which returns this, because this can be anything based on the context. You might have a function which returns a callback, or a function which returns another function which has a this, and it could be within an object which has another this. So the context could keep changing. So it's quite difficult. So let's just say TypeScript also has the same problem understanding this, like every other JavaScript developer, right? So they came up with a special type for that. It's called this type. So you can actually specify the output of something. Mostly this works only for methods. You can say this particular method returns this. How convenient. So, right? So it can be any this. We don't know what this is, but we know that it will be a this, right? And then you can do this. Sorry, no pun intended. Yeah, it's too many this year. So let's see what happens if we remove this. Nothing much. Let's try to remove these as well. Okay, still doesn't complain. But then, if you remove that, and then if you, still works. Damn it, TypeScript. You have a type which doesn't do much. Okay, it is supposed to fail at some point. Wait, maybe I missed something. Maybe I missed this. Come on, it works without this as well. Is it inferred? Yeah, see? TypeScript has become so good at inferring stuff, so it already infers the output as this, so it works, yeah. But I'm pretty sure there will be some use cases where it will not work without you actually having to specify this. So, but now you know. I also knew. I mean, never mind. So map types. This is really useful. So let's go back here. Okay. Really? How many examples did I miss? Okay, I'm going to cheat and copy from this. Okay, read only. Okay, I need a person. Person interface. So, and what does it complain? Didn't I copy the read only? What did I miss? What did I miss? Why is it duplicate? Did I miss something? No, right? You don't see anything more here, right? Okay. I have no idea what happened there. Strange, really strange. Ah, okay. Yeah. Okay, I think I know. Let's 1 second. Just let me try something. No, I thought it was already in context. No, it is not. That is really weird. And the same happens here as well. Wait a minute. Maybe I have a file with something? No. Yeah. Okay, it seems like it's part of ES5 library declaration as well. So let's just call it new for now. Sorry, I didn't notice that. Okay. Yeah. So the idea is that, say for example, like we have this particular class, and let's say we don't have this for now. We have this class, and more often you might have a need where, say, where you have to do something like this. You have to say you might have a need like this, and or say for example you might have a need to say something like this if you are using, say, strict null checks, right? But you don't want to change your original class because your original interface is still needed at some places, and also you need this new interface for some purpose, but you also don't want to duplicate this code because otherwise you might keep creating one version of each, and if you want to change this you also have to keep track of that and go and change everything, right? So it doesn't really scale well, right? So this is where the mapped type comes in. So let's take the read-only example, right? So we define a type and give it a name, add a generic syntax to it because it can work on any object, right? This is like we want to reuse this for any kind of such use cases. And this is the mapping syntax. So we already saw the key of syntax in the index typing. So here we say read only, fine, right? So this is like a looping kind of thing. So we say property or whatever. So this is the object. So whatever it could be. So let's just call it person for now to make it easier to understand, right? So we say person in, say, key of this particular type, whatever the type be, right? Person. So we are iterating all the keys of that particular type, and then we are also assigning the value of that as well. So this is like an iteration on all of your properties of that particular interface. So this iterates through every property and creates, it's almost like creating one line for each, right? For the actual value that we saw earlier. And when you define it, you pass the person here, and your output will be like this. So it creates that particular type dynamically based on the mapping you have specified. So this is, you can also say, for example, we also wanted null, right? So now, oops.
You're using read only.
Sorry?
You're using read only.
Yeah, doesn't work with read only, sorry.
No, you need to use read only new.
Your new type is called read only new.
Sorry. Thank you. That means this also. I changed that, but didn't change this one. Sorry. So, yeah. So it works fine. And the undefined on address is because of the optional typing, which is automatically being added. So it also does this. Let's also do this. So here we made everything as optional, right? So you can do anything that you can do with interface types. You can also add it to the same syntax and make it work. So you can add, say, intersections, unions, all sort of stuff. So yeah, that's about mapping types. We'll see some more complex example of mappings when we go into the React part. So there are a bit more useful ways where you can infer types from, say, other types or other functions without having to create them all the time. So that is very useful when you're doing React or Angular. Conditional types. Of course, you can also have conditional types, which is more, it's slightly different syntax. You have to make it a declaration. You have to declare a function to do that, where your type, mostly it is for return types. So based on the types you have passed and based on the value it outputs, you can return a type. So in this example, you get a type from a particular execution. Say, for example, let's execute and see this. Let's run this. Oops, what happened? Sorry, it only works in compile time, not at runtime. So yeah, so here it actually infers the type based on that execution. So you can see that it can be either string or a number based on the execution of this. So this is useful when you have, I don't know why you would use something like this instead of doing a union type or something like that, but probably there are use cases you can cover with this. At least I haven't come across one. Okay, so build tooling. So let's start with the obvious, Webpack. If you're doing a TypeScript project, you won't be where are we? You won't be doing TSC watch and TSC in it like all the time, right? You want a predefined tooling to do those things for you, right? You want a setup which runs, compiles everything, lints, tests, and everything for you. You don't want to do everything manually by running separate, say, a TypeScript server or a linting server and all those things. So there are multiple build tools that you can use. But one of the obvious choices would be Webpack. There's also other options like you can do with, say, Rollup or even Gulp if you are still into those. So an optimal configuration to only for TypeScript. I'm not talking about anything related to that. Like I'm not talking about how to do React or an Angular one. Only for TypeScript. So of course you need Webpack CLI, and Webpack Dev Server. Webpack Dev Server is for the hot reloading part. And this is a combination which works quite well. So you can use a plugin called Fork TS Checker Webpack plugin, Thread Loader plugin, Cache Loader, and TS Loader. So TS Loader is like the default TypeScript loader implementation for Webpack. And Cache Loader, of course, it provides the caching support. Thread Loader makes it multi-process. And this will fork new Node.js processors to do linting and etc. in parallel. This combination, only in this combination, if you use only thread loader, TS loader, you may not get as good as a performance that you might expect. So, but in this particular combination, this really performs well. It actually outperforms awesome TypeScript loader, which is normally used for TypeScript. Even though there is TS loader, most people just directly go with awesome TypeScript loader. But this particular combination actually performs quite well, and in some cases, or at least some of the cases that I was working on, this combination outperforms only using awesome TypeScript loader. But also with awesome TypeScript loader, you can also add say cache loader and few other combinations to make it perform better. But this normally works quite well. And of course, you need a source map loader and tslint loader if you're running tslint. And to finally optimize everything, you can use Terser Webpack plugin. It was like a successor to Uglify.js plugin. Uglify.js, I think, is not properly maintained anymore. So it's a fork. It's quite well maintained and quite up to date with all the features. This is for minification, finally. So this is when you are running on web development with TypeScript. And another option is to replace all these with awesome TypeScript loader. Works for most cases, but if you have a very huge project, then at least I encountered that, and we also the JHipster community encountered that awesome TypeScript loader was not being as performant as it used to be. So we switched to this combination, and it works quite well for Angular, React, and everything. So this is for Webpack, and of course, linting. Though TypeScript already does type checks and all those things, it doesn't do any sort of linting for you. It doesn't care about your code styling, right? So that is where TSLint comes to picture. So it's almost like ESLint, but for TypeScript. It also supports most of those similar rules. And for missing rules, you can always use the TSLint ESLint plugin, which provides all the missing rules from ESLint. And if you're doing React, you have a TSLint React plugin. And also, if you're using Prettier, you have a TSLint config Prettier for that. So talking of Prettier. So Prettier also supports formatting TypeScript and JavaScript. It's a great tool. If you don't want to care about formatting, and if you don't want to have a weekly retro with your team discussing about how to format your code, then you should use Prettier. I highly recommend Prettier. It's a great tool. Takes out a lot of worrying about how your code should look like. Automate it, add it to your commit hooks and everything. Then it just does the job for you. So TypeScript IDE and editor. So okay, the obvious choice would be VS Code. I have tried a few editors like VS Code, Atom, and there was one from Adobe called Bracket, and a few other lesser known ones, IntelliJ, Eclipse, and everything. But so far for TypeScript, VS Code provides the best support because it is written in TypeScript. It natively supports TypeScript, and it provides the best experience. It provides content assist, it provides IntelliSense, refactor support, formatting, language server, like lint integration, everything. It supports pretty good. And it has a plugin for TSLint. It has a lot of utilities, like say, for example, TypeScript Hero is a plugin for VS Code, which adds a lot of TypeScript utilities like class creations. And you can find snippet plugins for React, Angular, and everything. So VS Code is, I would say, the best when it comes to TypeScript support. Quite close is IntelliJ, but only in Ultimate Edition. The Community Edition doesn't support the TypeScript plugin. But with the Ultimate Edition, and if you're willing to pay for it, then it is also a good option. It provides pretty good support, but from my experience, not as great as VS Code, but still close enough. Of course, you have to spend some time to configure it properly in IntelliJ, whereas in VS Code, it just works out of the box. So we'll also see a little bit more of the other stuff when I do this part. For that, I'll create some applications. So if you are into Angular, Vue, or React, and if you want to kickstart using TypeScript, first places that you should look for is starters provided by them. So Angular CLI is a very good place to start your Angular applications. It out of the box provides TypeScript support, so that's the best place to start. And similar for Create React tab for React, it can bootstrap your application, and there is an option to do it with TypeScript. By default, it does with ES6, but you can always provide TypeScript blueprint as an option, and you'll get a TypeScript starter. For Vue CLI also, you can kickstart your projects, and Vue is officially the new version of Vue is written in TypeScript. So starting Vue with TypeScript is also a good idea. Since most of you are Java developers, and since we might have walked the same path of frustrations and all the problems and everything, so an optimal stack that I'm going to show you is from JHipster, of course. So it's mandatory that I show with this. So let's create an application. I'm not just doing it to show JHipster. I'm doing to show some stuff in TypeScript with React and everything. So let's go here. I'm going to create a React app, a monolithic app. We don't care about these things for this session. So we are only worried about React. We don't care. Okay, React. Sass, yes, let it be there. We don't care. And protractor. Okay. While this, I assume nobody wants to see this running, then I can just kill the npm install process and just go on with the code. Does anybody want to see this application running? Can I see a show of hands? Okay. Thought I would save some time by killing the npm process. Okay, let's look at the code. That's what we are here for, right? So we don't care about all this. Yeah, we do care about TypeScript part. Let's see tsconfig. So of course, when you're doing JS React, you have to enable JSX support because TypeScript supports it with a TSX extension. You can target it to ES5 or ES6, doesn't matter. Module system, you can go with common JS, but if you want to do tree shaking and some of the fancy stuff, then you want ES Next. Works quite well. So we switched it, I think, a few months ago. Works quite well. Yeah, some standard stuff, source maps, decorators, remove comments, and all those standard stuff. Out directory. You have to specify libs if you want to use newer features. Say, for example, if you want to use, say, ES 2018 or 2019 features, then you have to add those to the libs, so that you get, what do you call? You get these smaller libraries added to your code, which support some of the use cases that your browser might not natively support. So when you transpile your code, so type roots. This is how you provide types from the community for your libraries and stuff. And hello.js stuff. Okay, we don't care much about this. Import helpers. It's nice to optimize your code. ES module interop. This is good if you are using different kinds of import syntax. You can use the import syntax from ES modules, or you can use the import syntax from common JS. Both will be supported. Allow synthetic default imports. So this is to just avoid always having to do a default import. Okay, let's see. We also have TS lint here set up. So you can see this extends some of the basic rules from TSLint latest, some things from ESLint, some things from React, and from Prettier. So it extends these configurations already. You can see there are 2 sections here, 3 actually. This is empty. There is JavaScript rules. So that means with TSLint, you can have different set of rules for both JavaScript and TypeScript, which is possible. So you have JS rules and you have normal TypeScript rules. And you have Prettier setup as well. So, and what more? Yeah, in the package JSON, you can see all the scripts that is available to you. You have lint fix steps, running protractor test, starting your Webpack dev servers, test steps with just Webpack specific steps. You can see there is a Webpack command which actually uses a node instance with more memory. By default, it comes with 2 gig, which is not sufficient when you have a large project. And if you're running Webpack dev server and stuff, you will run out of that 2 gig pretty soon for a large project with a lot of source files. So you need at least 4 gig. So that's why you override that here. Then use that process to run other Webpack tasks. So if you ever have an issue with running Webpack on a huge project, then this is your solution for that. You also have Husky for pre-commit hooks, so that Prettier runs whenever you commit something and formats your code automatically. So Husky is quite nice compared to the traditional Git commit Git hook tools. You also have Webpack configuration. So you have a common Webpack configuration. So as we spoke about already, so there is rules for TypeScript. So we have cache loader, and we have a thread loader where it uses workers to speed everything up, and you have the actual TS loader itself, right? Which only we also say to only transpile. We don't want it to do any checks or linting, only transpile, because we already have where is it? TypeScript checking somewhere. Yeah, we have a TSLint loader here, which already does the type check also, because it runs type checking as well. So we have that. Then other stuff is not related to TypeScript. It is more related to the React app and other options like, say, JPEG or SAS and stuff like that. You have a dev build, which can run a dev server, Webpack dev server, and a browser sync plugin. You also have a prod profile, which does the transpilation, strips all the comments, does SAS compilation and everything, and also minifies and optimizes everything. So does your tree shaking and all, all fancy stuff set up, lazy loading, tree shaking, and everything. So let's look at the React code. Okay, this is our React code, so our index HTML, nothing fancy or important to see here, just an index HTML. So let's look at our React app. Yes, so this is the React app, the main file. So this is in TypeScript, right? So how this, when we started, I said that writing React in TypeScript gives a little less verbosity, right? I'll show you an example. Say, for example, let's go back here. Okay, let's keep this and create a new file called test.tsx. Yeah, I didn't include the libraries and stuff, so I just want to show you the code difference. Okay, and you might say, let's say, click button, and let's say this does something, right? Let's say it does something, and then you have your render method, which also does your rendering stuff. So it's quite common to see that in these kind of situations, you will have a constructor where you will actually do bind this, for example. Then you would define your state stuff here, right? The reason for this is obviously this issues that we have, because in traditional JavaScript you can't do this within a class. You can't have these kind of arrow members. If you had an arrow member, then you don't have to do the binding. That's the point. So, but with a TypeScript, since this is not in React, I think this will tragically fail. So let me show you an example of that. Util probably no. Hotels auth no. Okay, maybe auth. Is it a class? No, it's not a class. Yeah. So you can see this is a React class in TypeScript, right? So it's called header. It extends React component, right? I'll come to these, but before that, React components, and you can see it has a lot of such private, sorry, not private, like member attributes, class members. But you don't see any constructor where you have to bind this or anything. So this makes the code less verbose, and also you can assign your state like this. So this clears the overhead of having to add constructors all the time, having to bind any method that you define, and everything. And also you can provide your props and state to the type as a generic identifier. So it already knows about your state and everything. And say, for example, if I try to do it will fail because it's not defined in your state. It makes the use of React prop types irrelevant. You don't have to use React prop types if you are using TypeScript. It does it for you. So it saves you a lot of unwanted code which you are writing only for development purpose, right? Which is true if you will be writing some code for development purpose with TypeScript as well, but at least you get the benefit out of it, and you don't have to remove that code. You still have to remove the code during transpilation for the TypeScript specific stuff, which gets transpiled, but you're not adding that overhead onto your running code, right? The React prop types and stuff. Of course, you can use Babel and remove those code as well, but still, this is much more nicer to read. And another thing that you can do I want to show is, where are my reducers? Yes. So let's say we have a object, right? So we didn't specify any state. You can do the state actually like this. So instead of defining a type for anything, you can also create the type dynamically using the type of keyword for the state. This actually creates a type for you. And since we wrapped it in a read-only map type, it actually creates a read-only type of your object. So you can do this for anything. This is nothing specific to this particular code. Say, for example, if we copy it over to because what we have converter. I think this was okay because our TS config here is configured differently. So let's just get rid of that. So this also does the same here. So you can also use type mappings to dynamically generate types for your existing objects and stuff. This is quite useful. This avoids a lot of boilerplate of having to write interfaces, for your existing object. So if you already have an existing object with a good schema, just dynamically generate the type for that and use that type in other places. Is absolutely possible. And also, when you define the dynamic type here, then you are using that in your state and everything here, right? So your entire reducer is now type safe. And when you actually use that, let's say one of the usage, let's look at header again, for example. I think it's towards the end, probably. Okay, maybe not in header. Let's look at home. Yeah, here. So you can see an interface here, which is defined as properties of your this particular component, right? But it only says it extends state props and dispatch props, right? So let's see what state props are. So state props is again a dynamic type, a map type, right? Using the return type mapping, right? It says that state props are return type of map to state props method, and map to state props is an arrow method which returns an object. So this takes the type of the method's return and maps it to this particular type. So here, if you hover over, you see that this is of type account and is authenticated, and you can see this method returns account and is authenticated, right? So you are dynamically creating type based on your map state to props method, right? And also for dispatch props, it is a simply type of map dispatch to props, because this map dispatch to props is just a simple object. It's not a function. So you don't have to do the return type mapping there. You can just say type of. So here you'll get the type of the method. So these kind of usages allows you to reduce a lot of boilerplate in your actual code. This is not specific to React. I'm just showing this example because it is done here. You can do it to any project like Angular, React, or Node.js, or whatever is your TypeScript project. You can always use these kind of map types and index types to dynamically create types for your existing objects and like complex models without having to recreate interfaces and types by hand for them. So this is very useful in those kind of cases. So let's see. So you can see otherwise, without these kind of dynamic creation, you might have to create an interface for this and define everything by hand, right? All the state properties, your props and everything you have to define by hand. Now you don't have to do that. You can do that dynamically using TypeScript, so which is also quite nice. Let's just for completion, let me check what else I wanted to show there. Okay, nothing else, so I'll just run this. Where are we? Okay, let's run it. I think I created with Maven, right? Yeah. Come on. So how many of you already use these dynamic types in your projects, like map types and index types? No? Okay. Do you think it is useful? Okay. It's extremely useful. When TypeScript, so I had a project, React project in my current work, where we were hand coding the props for our component. It was a huge project. So for every React component, we were having this type with all the state and props and prop methods and every reducer methods and everything defined to pass us the prop. And as soon as TypeScript, it was a few versions ago, probably in the last few months that this feature was there, like probably within the last 6 months, I guess. So as soon as this feature was there, the first thing I did was get rid of all those code, the handwritten type code, and assign dynamic types for that. So I think it probably removed a few thousand lines of code by just converting to dynamic types, and everything still works the same. and we still get the same type safety, everything, but much reduced code, which is really nice. So the app started. Yeah, this is what you get. Admin. This is like an obligatory demo. Like have some user management, metrics, health, blah blah blah. So right, so yeah, not gonna go into much of this. Just gonna kill this. I'm gonna cd out mkcd ts angular. I'm also going to show the code with Angular as well, because I have a few more minutes. By the way, did I show that all the test was also returned in TypeScript? Yeah, the protractor test, they were also returned in TypeScript. Works quite nice. You can have your page objects in TypeScript, and then you can type them. It's quite nice. So the content assist is really nice in those cases. And you also have your just tests, again returned in TypeScript as well. So yeah, it's TypeScript everywhere. So did I generate it? Why does it look so fast? Yeah. So this is the Angular version of it. Similar configuration, like you have tsconfig, tslin, blah blah blah, prettier, husky, extremely similar Webpack configuration, except for adjustments for the framework specific stuff. And web app, you also have similar structure. The only difference is this is all in Angular. So where is my main app? Yeah, you can even see the Angular logo. So yeah, like all annotations everywhere. So this is really huge annotation. So you also have some. Somebody asked me, I think few of you asked me like if annotations will slow applications down. So and I said that we create applications in JHipster for both Angular and React with same structure, same feature, same feature set, like everything, and we don't actually see any difference in performance. We normally do Lighthouse performance analysis on those. We do PWA with it and everything, and we don't see any difference in performance. But that doesn't mean there isn't any performance penalty by using these, because any line of code you adds bytecode instructions, and that's going to affect your performance. So, but doesn't mean that this is going to add extremely huge performance penalty. So I think it's quite okay to use this. So what else? Yeah, that's all for. Of course, you can generate projects with JHipster. It's quite easy. You just need to. You don't even have to install it. You can say npx generator JHipster and just run this, and it will ask you questions, answer those. It will create the project and see how things are done. You don't have to use JHipster, but just look at the React or Angular code, and you might be able to take something out of it and like put in your own projects or stuff like that for educational purpose. And where is my yeah, I mean, this is the only recommendation I think that matters. So these are all tools. So once you know the language, any framework or any tool is just another set of code. So don't spend time learning those frameworks, but on the language itself. And TypeScript website has pretty decent do's and don'ts. Please read them. They have very nice or very useful information out there. Yeah, that's all. If you're interested in my book, you can check this out, and thank you. So we have 4 minutes left if you have any questions. Yes, thank you. I mean, if you have any questions, you can also come down. Like, I have 4 minutes. Probably I can't. I saw somebody raising hand, but I can't. Or I don't know if you have a mic or something there. I don't know. How does it work? Yeah. Probably you can just come down and like, it's easier.